With this video, we present an integrated lateral design approach for structural concrete slabs using ETABS Builder 2009 and ETABS. Assume you have an ETABS model, which typically is modeled as a simplified geometry of your structure. Therefore, you would have your geometry, gravity, and lateral loads defined in ETABS. We want to design our slab in detail, so the first step we will go through is to export our geometry, gravity loads, and lateral analysis solution from our ETABS model. Prior to importing into ETABS Builder, we will validate the ETABS data using ETABS Integration Console. We will then bring the slab and loading information into ETABS Builder and carry out a detailed analysis and design. The demo to follow outlines these steps. We will start by exporting our geometry, gravity, and lateral loads from the ETABS model. This will be done in two steps, once for the geometry and gravity loads, and then for the lateral loads. We will use the print tables function of ETABS in order to export the necessary information. The input table carries all the geometry and gravity information. The printed input tables window gives us the option to select which components we want to export. In our case, we will select all. We also have the option to specify which loads are exported. We will only select a few. The information will then be printed to a file, which will be used later for the import. Now that the geometry and gravity information has been written to a file, we can export the lateral loads needed for the design using the print tables function. In this case, we will select the analysis output, which holds the solution of the model. We are prompted to select which type of analysis results to export. We will select all the options. The loads and load combinations to export will also be selected. We will then write the information to a file. All the necessary information has been gathered. We can now close out of ETABS. Prior to importing into ETABS Builder, we will need to validate the ETABS data using ETABS Integration Console. The console was kept as a separate tool, allowing individuals who do not have an ETABS license to benefit from the integration. The option is given to import the geometry, gravity loads, and lateral loads, either individually or in combination. Depending on the import option selected, the integration console will require the location of the files created in ETABS previously. We have the option to select which levels to import. In our case, let's go ahead and select the entire structure. A location needs to be defined for the output file. Once next is selected, an equilibrium check is performed. A summary is reported indicating the status of the check for each of the levels imported. The results for a given level can be seen in greater detail. We select Finish to exit out of the integration console and launch ETABS Builder 2009. We have selected 3D finite element as our floor system, RC only as our design scope, and dynamic rebar design for our extension modules. Ensure ETABS is selected and select OK to open Builder. Let's go ahead and import our model so we can start our detailed design. In the File menu, we will select Import and ETABS. We select the file which was created from the integration console. We are then prompted to review and edit the import options available to us. Select which floor to import. The option is also available to select which components to import. This is where you can incrementally bring in changes from ETABS. Under Loads, Load Cases, we will go ahead and select All. Next, we will select both of the load combinations available and select OK. At the completion of import, a lateral load status check window will appear showing the results of the various checks Builder has run for each of the load cases, such as equilibrium and compatibility. In the case where the solution is slightly out of equilibrium, we have incorporated the redistribute air function, which will distribute the air and bring the load case to equilibrium. The floor has been successfully imported. Let's go to the perspective view to get a closer look. As we zoom in, you can see the model in closer detail and the force actions which were all brought in from ETABS. Let's go ahead and open this moment at the top of the column and view its details. The load case is lateral seismic X, with the magnitudes as shown. We can also go ahead and open the moment at the opposite end of the column. If we change our view to front view, you can see the force actions which are applied at the top and bottom of the columns and walls. Essentially, we took a slice out of our ETABS model. If we select this load, it is a gravity load and part of the load case dead, and is a patch load with a magnitude of 25 pounds per square foot. At this point, we will go ahead and make one minor modification to our load combinations. We will go to Loading, Load Combination. You can see we have two default load combinations, Service and Strength, and the two which were imported in from ETABS, COMB1 and COMB2. We will go ahead and swap the dead and live load cases for the service and strength load combinations to the dead and live load cases which were brought in from ETABS. Let's also go ahead and set the two load combinations which were brought in from ETABS to an analysis design option of strength. Once we have completed our modifications, we select OK. We will also go into the Criteria menu and turn off the option to automatically generate column strip, middle strip for this video. Adapt Builder is based on the latest finite element technology, whereby an adaptive organic mesh generator automatically detects the intricacies of a floor system and provides well-balanced and consistent quadrilateral finite element cells for an accurate and reliable outcome. We can now analyze the model. At the completion of the analysis, we can view the slab deflections to gain an understanding of its behavior. We also have the ability to calculate the rebar requirement at any specific location within the slab by creating a manual design section. This allows us to see as far as rebar goes what is required. Once design is complete, we can double-click on a design section and view the results. Let's review the rebar required for all the load combinations. The manual design sections are also great for quick checks and details, but for a more efficient design for the entire floor system, you're better off creating support lines. We start by creating the support lines in the X direction, and then conclude by defining the support lines in the Y direction. In essence, we are defining the load path for the X and Y directions. At the completion of the support lines, we need to then go to the FEM menu and generate the design sections. We can now see the tributary regions which we automatically created using the support lines as a guide. Each support line now has design sections which are associated to it. The frequency of the design sections can be defined by you. Let's quickly review all the strips to ensure they are what we had intended. Everything looks fine, so we can now go ahead and design the design sections. At the completion of the design, we will use the Result Display Settings tool to briefly review the outcome of our design. We will look at the total design moment for several load combinations. The seismic X-only combination will show us the effect of the seismic force on the slab. In toggling between the X and Y direction, we can noticeably see that the X direction is the primary. The deflections for the various load cases can also be graphically shown in this view. We will go ahead and generate the rebar now. Keeping all the default settings, select OK. This is our reinforcement drawing. Let's go ahead and clean up our view by focusing in on the top bars only in the X direction. Now let's zoom into a column to have a look in greater detail. We can clean and modify the rebar as we wish, utilizing the flexibility the Dynamic Rebar Design module offers. Notice how the spacing changes automatically due to the change we made. As we edit the properties of the bar by changing the spacing and length, notice how the changes are automatically recalculated and updated. We will now substitute some of the bars calculated with the typical base reinforcement mesh, which will reduce the total calculated bars. Let's add a top and bottom mesh of number 4s at 18 inches on center. We will then redesign and generate the rebar drawing. In this case, Builder will take into consideration the mesh created, therefore resulting in less overall reinforcement. This time around, we will keep envelope as our load combination, select library lengths as our bar lengths, and select aligned orthogonal as our bar orientation. Looking at our newly generated rebar drawing, you can see the amount by which it has been reduced due to the addition of our typical base rebar. We now need 28 number 5s where we previously needed 33. If we go back to our design strips and select one, we will be able to see the rebar generated in elevation. Let's zoom in to get a closer look. The demo has ended, and we will now conclude this video by reviewing the key advantages of using AdaptFloor Pro to design concrete slabs modeled in ETABS. The first key advantage is that the integration console recognizes and extracts applicable loads. The integration console also automatically performs an equilibrium check on the extracted loads. If the equilibrium check passes, we continue in our design process. However, if needed, there's an algorithm that can redistribute the errors from the ETABS model. Once the geometry and lateral loads are verified and imported into AdaptFloor Pro creates the industry's most accurate 3D FEM model of the slab system and properly combines the gravity and lateral load cases, resulting in a more reliable solution for required rebar and its distribution. This is particularly true at slab discontinuities.